Alright, we're doing count hills and valleys in an array 2210. Hop into this, screen it. Okay, a lot of text. You are given a zero indexed array nums, and index I is part of a hill if the index I is part of a hill if the closest non-equal neighbors of I are smaller than nums of I. Similarly, I is part of a valley if the numbers closest to equal to are larger than nums of I. Sure. So you can think of it intuitively. The top value is the highest, the smallest value is the lowest, which are the valleys, lows, and the hills are the highest. Adjacent indices I and j are part of the same hill or valley if they equal each other. Note that for an index to be part of a hill valley, it must have a non-equal neighbor on both left and right. Turn the number of hills and valleys. So at index 0, there are no non-equal neighbors on the left. So index 0, there is no non-equal Okay, let's just keep going. That's a little confusing. All right, the closest non-equal neighbors of 4 and 2 and 1. Since 4 is greater than 2 and 4 is greater than 1, it's a hill. Okay, so essentially it's a peak. For 1 here, let's look at 1 really quick. Wait. Wait, that's for 1? At index 1. Sorry, okay. So at index 2, the closest non-equal neighbors are 1 and 4. Since 1 is greater than 1 is less than 4 and 1 is less than 6, 2 is a valley. Okay, so it's part of the same. So if it's similar, we have to check the end value. I see. So if you have a valley, you have to like continue checking. Interesting. So yeah, there's some little edge cases here we'll look into, but essentially, yeah, there's gonna be 0 if it's all decreasing. Essentially, anytime you hit a peak, you want to return it. And you might not know if you have a peak or a valley for a little bit, so you have to kind of keep track of it. Um, so, well, we are going to do a for loop. And we are going to look for the either if it's a valley or if it's a, let's pretend that we're always just looking at the left and right. We'll look if it's a valley or a hill by just looking at the, so we'll do the valley first. We also need a count here. Valley check looks like this, where if we also have to one can never be a valley or a hill because the first index, so we can skip over it. So if nums of I is greater than or less than, put nums of I minus 1 here, and nums of I is less than nums of I plus 1. So we're actually going to have to do a minus 1 here because we'll be checking one extra. Count plus equals 1. And then very similar, if nums of I minus 1 is greater than nums of I and nums of I Um, this is backwards actually. The valid check should be, this should be greater. And yeah, that should be that way. Okay. This is wrong. So we're doing the hill check. So the current value should always be the greatest. Okay. And that would be if we didn't have to consider duplicate values. So for duplicate values, we'll have to store the last scene. Just gonna be nums of 0. And essentially what we'll do is yeah, so if nums of I equals last scene, we have to continue and essentially skip over that value because it's useless. And actually, we'll have to check last scene instead of nums of I minus 1. Because it might be back in the past. We'll be checking this value and this value. If it's in a valley, we'll be at this index and we'll check its next value. It's a little bit different than what I'm thinking here. So last scene. So if it's next value equals I, skip it. If its next value equals what we're currently at, skip it. And then set last scene. We'll just reset last scene here. And we can just put this here. How do you do this? Like that? Yeah, okay. So we're checking, we set the last scene value. So if we see a 1, and the next value is a 1, we skip it. And if not, sorry, that's last scene is it's not. I think that's right. It's a little weird to think about. Because if here would be set to 2, 4, then it would get set, it would skip 1. It wouldn't skip this one. Then it would look at 4 and 6. Yeah, okay. Let's just submit it. We'll say it's a decently hard, easy. Forgot colon here. And oh, I also have to add count plus equals 1. All right, passing those cases, you'll submit. Nice. Yeah, I think that's kind of the best solution I would go about here. I don't really see a better one, I don't think. Let's just look at some solutions though. 2 lines of code. Okay, I mean, come on. Come on. I mean, this is interesting. They're doing like two different arrays, two loops. I don't know. I don't really know what they're doing there, but let's look at some other really quick ones. Just want to say, yeah, a little bit hard. I think this is a really good solution. So yeah, that's it. Thanks everybody, and stay strong.